college requires applicants to have ACT scores, in the top 12% of all test scores. The ACT scores are normally distributed with a mean of 21 and a standard deviation of 4.7. So if you want to be in the top 12%, you need to, the percentile means that if you're in the top 12%, that means that there's 88% of you that are below that, right? So if they're in the top 12%, find the lowest test score that a student should get to get the college score requirement. So the first thing I need to do is find the z-score for the 88th percentile. Whenever you're using inverse norm, you find the area below. Okay? So area below. So I'm going to do inverse norm. Okay, so second vars, inverse norm. The area below is 88%, right? And then you get a z-score of 1.17. So the z-score is 1.17. So again, I'm going to use the mean plus the z-score times the standard deviation to get the value. So the mean is mean plus z times the standard deviation, which is equal to, the mean is 21, the z-score is 1.17, and a standard deviation of 4.7. That's going to be 28.99, so it's going to be 29. So that person has to at least earn a 29 on the ACT. That's not fun.
12%.
Yeah,
that's aggressive.
It is aggressive. Okay, so 1,500 students are randomly selected. How many would be expected that would meet that college's requirement? So if we have a z-score if I know the z-score, the value is 29, it would just be 12%, correct? Times this amount. So I'm going to do 12% times 1,500. Because if you want to be in the top 12%, right? That's kind of a silly question. Sorry, guys. 0.12 times 1,500. That gives me 180. Approximately 180 kids out of the 1,500. How does the answer to Part A change if the college decides to accept 18% of all test scores? The score is going to what? Is it going to go lower or higher? Lower. Okay. So in our other retake ticket of Part 1, which is basically, we've kind of already done that. But we want to find the area to the left. What's so nice about this is it's telling us area to the left, area to the right. So left means upper bound, right? The right is a lower bound. And then between, this is going to be your lower bound, and this is going to be your upper bound. And then, okay, so let's go ahead and do a few of these. So if you have a z of 1.54, here's your mean, here's one standard deviation, here's a little bit more. So we want to find this area right here. So this is, did you get 0.9382? Okay, and then to the right, so here's 0, here's approximately 1 standard deviation. We want to find to the right, so it's above. So now my lower is negative 0.95, and then I just do a really high number. And that's approximately 0.8289. And then between, here's your mean. And then, so it's approximately like this. So you're going to do second FARS, normal CDF. Your lower bound is negative 0.44, and your upper bound is 1.18. And I get 0.5510. Okay? Now, let's pay attention to what we're doing here. Find the area to the left of negative 2.97. So remember, this is a sad normal curve. So this is 0, negative 1, negative 2, and this is negative 3. So it's approximately here. And then to the right of 1.66. So here's 1, here's 2, so it's approximately here. So you're going to have to take these two areas and add them together. So let's do the easy one first. So if I have one z-score is negative 2.97. Oops. I get 0.0015, right? And then to the right, this is going to be my lower bound now. So my lower bound is going to be 1.66, and my upper bound is some big obnoxious number, and that's 0.0485. So 0.0485 plus, not minus, plus 0.0015 should give me 0.05. Okay. Not too bad, right? Now we're doing the probability of greater than, so this is going to be your lower bound. And then here, this is your lower bound. This is your upper bound. So these should go very quickly. I've got normal CDF. So my lower bound is going to be 1.45. So it's 0.0735. And then this one is second. I've got negative 0.95. That's your lower bound. And then your upper bound is 1.44. And that gives me 0.754. Which makes sense because this is a little less than 1 standard deviation below the mean, and this is almost 1.5 standard deviations above. So if I go 1 standard deviation above and below, that's 68%. So it's a little bit more than that. So that makes sense. Okay, find the z-score that has 62.8% of the distribution to its left. So this is what we're always using right here. This is 0.628. That's our area below, right? So we're going to use our inverse norm. So I'm going to do second vars and go to option 3, and the area is 0.628. And that gives me a z-score of 0.3266. Now, if we do 62.8 to the right, we have to do 1 minus 0.628. We always have to use the distribution, the amount of area to the left when we're doing inverse norm. So 1 minus 0.628 is 0.372. Okay, now if you want to find 80% of the scores lie between these two z-scores, that means there's 40% here and 40% here, right? Does that make sense? So between one z-score and another z-score. So if this is 80, these two add up to 20, right? So this is going to be 10% below and 10% above. So I want to find the z-score where we want to find one z-score where the area is 0.10, and then I want to find the area where it's 0.90, right? Because if it's 10% above, there's 90% below. Does that make sense? Okay, so I'm going to do inverse norm first. And the area below is first 10%. So the z-score for that one is negative 1.28. So that's negative 1.28. And then I'm going to find the area where it's 90%. So second vars, inverse norm, and that's 0.9. And that's going to be 1.28. Makes kind of a lot of sense, doesn't it? So for this last one, we're going to do the same thing when we're doing 99%, right? In between, there's 99%, right? So there's 1%. So to do, this area is going to be 0.005, right? And this area is going to be 0.005, right? So one of them is going to be 0.995, right? Because we want to find this, right? This area is 0.995, and then one of them is going to be 0.005. So to find, this is 2.57 or 2.58, right? 58, right? And this is negative 2.58. Do you notice that they're basically the same thing, except one's positive, one's negative? Right? Okay, so you have a pretest to do, and the front page of this other one. So why don't you guys work on that? And then I will go ahead and post the answers for you.